In this lecture, we're going to talk about higher dimensional lines and planes. So let's first talk about lines. Now, to describe higher dimensional lines, we need to first talk about vector value function and parametric equation. So let's first talk about the vector value function. Normally, when we think of a function or function in the usual sense, those functions will transform from number. They will change from a number to a number. For example, if I have, let's say, like f of x is x squared plus 1, this guy will change a number from a number x to a number x squared plus 1. Now, however, if we have vector value function, we're going to talk about function that change from number. We're going to talk about a function that sends number to vector. So now that means my f of, so let me use a variable t here. My f of t is going to be a vector now. So let's just take a look at the first example down here. So now my function, my f goes from r to r squared. So here the domain of my function is just r, it's just a real number, so this is scalar. But the range of my function is r squared, so now this is a vector. So now I have my function f of t here, which sends a number t to this vector here. So let's try to compute some few values of f. If I want to compute f of 0, well, it looks complicated, but it's actually not that bad. F of 0. I can compute this by just plugging in t equal to 0. So it's going to be negative 3, 1 plus 2, 1 times 0 plus 2, 1 times 0. So I'm going to get negative 3, 1. Okay, let's try the next one. F of 1 is going to be just negative 3, 1 plus 2, 1 times 1. And this is going to be, let's see, negative 1, 2. And the last guy, f of 2, is going to be just negative 3, 1 plus, plus 2, 1 times 2. Plus 2, 1 times 2. And this is going to be 1, 3. So now here are the values for my vectors. And here are the values for my function. And you can see that they are all vectors. These are still in 2 dimensions, so we can kind of sketch the graph for this guy. So let me actually just pull out my graphing calculator. So now, let's see my black vector here. This is actually going to be the vector, which is the result of my function. So it's going to be negative 3, 1 plus 2, 1 times t. And when my t is 0 here, we get negative t, 1, which is what we get earlier. Now, if my t is equal to 1, let's see what we're going to get. When my t is equal to 1, I'm gonna get negative 1, 2, which is what we get as well, which is this black vector here. And when my t equal to 2, I'm gonna get 1, 3, which is kind of what we get earlier, and here is the vector. Now, I can try different value of t, and this is what my vector is going to look like. Now, if you just look at the tip of my vector, it should follow a trend, and this trend is actually this green line here. You can kind of see the tip of my vector is always on this green line. Now, what is this green line? Well, we can see this green line as being this point, negative 3, 1, which is kind of we can view this as the origin of my vector. So this is going to be the blue point here. Now I'm gonna add another vector to this blue point or the blue vector, and my vector is gonna be a multiple of this blue vector here. We can see that when t is 1, it's going to be just vector 2, 1, and when my t is 0, it's just going to be a 0 vector, and when my t is 2, it's gonna be twice of the vector. When t is 2, it's going to be twice of vector 2, 1, which is 4, 2 here. So this kind of explain why my black vector is actually just the endpoint of the blue vector. It's just a multiple of the blue vector here, which is a multiple of 2, 1, added to my starting point, which is negative 3, 1 here. And that's how I get this green line. By the way, it's just gonna be, I start off with the blue point, and I add that by a multiple of the blue vector. And now there is another way that I can view this line. I can kind of compute this and combine them into one vector. So if I look at the coordinate for this guy, it's going to be -3 plus 2t. -3 plus 2t. So that is going to be my x coordinate, and my y coordinate is going to be just 1 plus 1t, which is 1 plus t. And that is going to be my coordinate. So instead of looking at this as a vector value function, I can also consider this very same thing as just two functions. So this is going to be my x, and this is going to be my y. So this perspective is going to correspond to another way that I can look at the equation for the line here. This is called the parametric equation, and that is going to be the same thing that we have down here. So a parametric equations are basically a group of functions where you have common independent variable. In this case, I'm gonna have two functions x and y that have the same variable t. So this x -3 plus 2t is kind of what we have here, and my y 1 plus t, which is also what we kind of have here. Now then, well, we have seen the graph for this guy earlier. It's going to be just the same graph. It's going to be the same green line here. But for now, let me also show you another way that I can plot the graph for this one. Well, I can actually try to eliminate the variable t here. So if I try to do that, let's see. So my t, if I try to manipulate my first equation, my t is going to be just x plus 3 over 2. And then I can substitute x plus 3 over 2 into this t here. So my y is going to be just 1 plus x plus 3 over 2. And this is going to be, let's see, 2.5 plus 0.5x. So that means I should be looking at a line whose y-intercept is 2.5. And the slope is going to be 0.5. And that is exactly the line that we have been looking at here. So this green line, the y-intercept you can see is 2.5 and the slope is 0.5.